All right, you guys, this is your second assignment for week 4, and what we're looking at this week was systems of equations. Our first assignment was solving systems of equations using elimination, and today we're going to review how to solve using substitution. So I'm going to fill out this little section on the side. We'll talk about the steps, and then I'll give you 2 examples. And your assignment is going to be to do these 6 problems on your own piece of paper and put it in Google Classroom to submit it to me and Miss Edson. So first of all, substitution is used when one equation is set equal to a variable. So for example, you may see something that says y equals 2x plus 6. So as long as the y and the x are on opposite sides and the y is isolated, then you can use substitution, or they may isolate the x instead. So you might see something like x equals 3y minus 8. All right, so that's how you know when you're going to use substitution. And if you look at your 6 problems for today's assignment, all of them have one variable isolated. So I'm actually going to go through and I'm going to box off each equation that has the isolated variable, and hopefully that will at least give you guys a little bit of a head start when you go to do them on your own. Okay, so I'm going to put the steps over to the side right here, and then I'm going to give you guys a couple of examples. So first example we have is y equals negative 3x plus 5. So if you look at step 1 says to put a box around the isolated equation and the variable in the other equation. So I kind of started doing that for you guys, what I just did on those 6 problems, but there's one extra step we need to do. So besides putting the box around the isolated equation, then also notice it says put a box around the variable in the other equation. So here I notice it was the y that was isolated, which means the y is where I'm going to plug in that other equation. So I'm going to now take this bottom equation and I'm going to say 5x minus 4. Now instead of y, what this is telling me is y is the same thing as negative 3x plus 5. So instead of y, I'm just going to replace it with negative 3x plus 5. The y goes away completely because it's been substituted in. Now, the whole reason we do this is so that we only have one variable. So now we only have x's. So what we're going to do is first we need to unlock the parentheses. And in order to do that, I have to distribute. So I'm going to get 5x. And then negative 4 times negative 3x is going to give me positive 12x. And then negative 4 and positive 5 is going to give me negative 20. And that equals negative 3. All right, so now we're going to look at combining like terms. So my 5x and my 12x becomes 17x minus 20 equals negative 3. And I forgot, usually when we solve equations, we put a line down the equal sign so that we can clearly see the 2 separate sides. So now I'm going to add 20 to both sides. And when I do that, I end up with 17x equals 17. So my last step is going to be to divide by 17. And 17 divided by 17 gives me x equals 1. Okay, but remember, the whole point of solving a system of equations is you want to know where the 2 lines intersect. And that means you need an actual point. And a point requires an x and a y. So I need to take x equals 1, and I need to choose one of these 2 equations to plug it into. I always choose the one that already has the isolated variable. It will always require less work than choosing the one that doesn't have an isolated variable. So I'm going to choose y equals negative 3x plus 5, but x is 1, so y equals negative 3 times 1 plus 5. So y equals negative 3 plus 5, so y equals 2. So we say they intersect at 1, 2. Oh, oops, sorry. So there we have our final answer. And I kind of forgot to point out the steps as I was going through, but so yeah, substituting, step 2 was right here. Solving, that was all this stuff. and then plugging in your answer into either original equation to solve for the other variable. But again, my advice is always to plug it into the one that's isolated already. So let me give you one more example. We'll follow the steps again. All right, so step 1, put a box around the isolated equation and around the variable. Now notice with this one, the bottom one is isolated and it's an x instead of a y. So now we know that I'm going to take whatever x equals down here, I'm going to plug it in wherever I see x on the top. All right, so I'm going to say 2, and instead of x, I'm going to put y plus 1, because this is saying x is the same thing as y plus 1. Just like when you get a number, like x equals 5, and you replace x with 5, we're just replacing it with this entire thing. So 2 times my x, which is y plus 1, minus 3y equals 1. So we substituted, we just did step 2, we substituted the isolated equation into the other equation. Now we're going to solve. It's just like before, I need to distribute. So I end up with 2y plus 2 minus 3y equals 1. I'm going to combine my like terms, so I get 2y minus 3y, and 2y minus 3 is going to give me negative 1y, but I still have plus 2 equals 1. I'm going to bring this up here. So that's negative 1y plus 2 equals 1. Now I'm going to subtract 2. I get negative 1y equals negative 1. My last step is to divide by negative 1, and I get y equals 1. Now it's easy to stop here and just say, oh, I'm done, I have an answer. But remember, just like I said last time, we want to remind ourselves we're looking for where they intersect, which is an x and a y. So I have y. My advice, always plug it back into the isolated equation. So I'm going to plug my y in. It's going to be x equals y plus 1. But y is 1. So x equals 1 plus 1. So x equals 2. And then again, we always remind ourselves what that means is they intersect at 2, 1. Okay, now just one more look at the worksheet, just to kind of help you guys out. I'm going to go through and I'm going to box those variables for you. So this top one, we already boxed the isolated equation. And then there's that y, that's where we're going to plug it in. For this one, it was x that was isolated, so now we're going to box the x. For these middle two, it was y that was isolated, so we're going to box the y. Here, also y was isolated, box the y. And then x was isolated here. And then x was isolated here. Oops. All right, so kind of move that out so you can take a screenshot if you want. As always, you can reach out to me or Miss Edson, and we can do a Zoom meeting with you or whatever we need to do to help you. If you have any questions, please let us know.